chapter which we were discussing was the landforms and their evolution. Under that, till now we have discussed about the action of the river, how the different landforms are formed by the erosional action of river and of course, by the depositional action of the river as well. So, dear children, now we will be taking up the second most important agent in forming the various landforms, that is the underground water. Underground water does a threefold action of erosion, transportation and deposition, like all other agents of gradation. Limestone area where the underground water is very effective is known as karst topography. Now, the erosional work of underground water. Underground water flows slowly and its physical erosional power is negligibly small. Erosion by underground water includes the different types of activities, for example, corrosion, attrition, solution and hydraulic action. So, these, dear children, are the different types of the erosional activities done by the underground water. Out of all these, the solution is the most important process. Pure water is not a good solvent, but it becomes an active solvent when it comes in contact with carbon dioxide gas. When the rainwater percolates into the rocks, it dissolves some of the rock particles by solution. Limestone, dolomite, chalk are some of the most soluble rocks, and such rocks are easily dissolved in rainwater which contains carbon dioxide. Because, dear children, when the rainfall comes on the surface of the earth, this rainwater has to travel the area of atmosphere where the gas gets added to the water, and that does the action of the solution in the different rocks. Different rocks means only the rocks containing the limestone. Erosional features formed by the underground water are, for example, lapis, sinkholes, swallow holes, doline, uvalas and caves, etc. So, we will be discussing all these features separately. So, children, first we take up the formation of lapis. When underground water carrying carbon dioxide enters the cracks and joints in a limestone area, it dissolves the surrounding rock and widens the cracks and joints by its solution activity. The long furrows with the vertical walls are formed, which are known as lapis. So, look at the screens and you can have the visual of the lapis. So, that means the deep furrows formed by the underground water. Now, we take up the sinkholes. Sinkhole is a funnel shaped depression which is an average depth of 3 to 9 meters. Area may be 1 square meter or more. Sinkholes are developed by the enlargement of the cracks due to the continuous solvent action of the rainwater, and the rainwater is very active because the carbon dioxide gas gets mixed up with the water. Areas of large number of the sinkholes is dangerous for the construction work, especially for the railway tracks and the roads. Sometimes the streams disappear into them, leaving their beds dry. With the passage of time, the sinkholes join with each other, creating the huge depressions, and areas where the sinkholes are found are the limestone, dolomite and the gypsum areas. Yes, children, on the screens you can have a visual of the sinkholes. Sinkholes, you see, it's a great depression formed, and naturally in these depressions the rivers disappear while moving on this area. Now we take up another feature that is known as swallow holes. These are cylindrical in shape, lying underneath the sinkhole at the same depth. Surface streams often sink suddenly and disappear underground through them, and they justify their names by virtually swallowing the subsurface streams. So, that is how they are known as the swallow holes. Now, on the screens you can have a visual of a swallow holes which swallows the subsurface streams. Now, we take up another feature that is known as dolines. When a sinkhole is enlarged due to the solution of the rocks by the underground water, it becomes doline. Dolines are funnel shaped at the surface and cylindrical below it. Children, they are 8 to 12 meters wide and 4 to 20 meters deep. So, this is a visual of the dolines. But children, you must be noticing that all the features which we have discussed till now, sinkholes, swallow holes, dolines, almost the same feature looks like, that is the depressions, round depressions, the deep depressions, they are formed by the underground water, taking the different shape and giving them the different names. Now, the another feature is uvalas, the walls of the adjacent dolines when they collapse, and this collapsing is again due to the solution by the underground water. They get converted into the bigger holes known as uvalas. So, uvalas like the dolines, but they are bigger in size. They are vertical walls, they have closed basins and oval shape. Now, this is a visual of uvalas. Now, we take up the caves which are formed by the erosional action of the underground water. In certain areas, there are hard insoluble rocks at the surface and the soluble limestone below it. Then what happens? The underground water dissolves the limestone from below, while the upper rock, which is a hard rock, that is intact like a roof, and thus a cave is formed, which is known as a cave or cavern. So, this is a visual which shows you how the cave that looks like, because the bottom gets eroded, but the top area, being the harder rocked area, remains intact. Now, dear children, after the erosional work of the underground water, now we take up the depositional work done by the underground water, and the features formed by the depositional work are stalactite, stalagmite and cave pillars. So, first we take up that what the stalactites are. These water containing limestone in solution seeps through the roof of the cavern or the cave in the form of the continuous chain of drops. Then what happens? The portion of the drops hangs on the roof, and on the evaporation of the water, a small deposit of limestone is left behind, contributing a formulation of a stalactite. Stalactite grows downwards from the roof, because dear children, as I have told you that when the water seeps through the roof of the cave, then only this feature starts forming. So, naturally the formation of the stalactite grows downwards from the roof. So, since it is from the roof towards the downside, its thickness is maximum near the roof and it thins out downwards. So, on the screens you can have a visual of the stalactite. So, that is, these are the features which hang on the roof of the cave because of the seeping of the lime water. So, with that seepage, what happens? As I have just told you, that the water evaporates, but some part of the lime only stands with the roof, and this formation starts forming towards the downward movement. Now, the another feature, depositional feature of course, is the stalagmite. The remaining portion of the drop falls to the floor of the cave. This also evaporates, leaving behind a small deposit of limestone, aiding the formation of the stalagmite. So, since the stalagmites, they are formed from the bottom towards the top area. So, bottom is the floor of the cave and top area is towards the roof of the cave. So, the stalagmites are thicker and flatter, rising upward from the floor. So, dear children, on your screens you can see the visual of stalagmite. So, that means this picture shows that how the formation starts rising upwards from the floor towards the roof of the cave. Dear children, the last feature which is formed by the deposition action of the underground water is known as cave pillars. Sometimes a stalactite from the above and the stalagmite from below develop towards each other and combine together to form a pillar. So, that feature formation is known as a cave pillar. So, this visual shows you how the stalactite from the roof side of the cave and stalagmite from the floor of the cave, they start expanding and both at one point of time they meet each other, they join each other, forming the cave pillar. So, dear children, we have now discussed the work of the underground water as we discussed the work of the river. The underground water also does all the three activities: erosion, transportation and deposition, and there are various landforms formed by the underground water as well. Right now, we have discussed the erosional features formed by the underground water and as well as the depositional features which are formed by the underground water. Now, we are left with few more agents of gradation which we will be taking up later. For example, the work of the wind, the work of the glacier, which is also known as the moving ice. Thank you, children.